Hi, welcome to today's session on parallel and perpendicular line equations. So a lot of you might already be aware of exactly what parallel and perpendicular mean, but just going to have a quick reminder. So a parallel line will have the same gradient as another line. These lines will never ever intersect, in which case they'll never ever cross. When people are talking about parallel lines, to me, normally they use train tracks as a good example. A line that's perpendicular, will intersect, it will cross the original line and it will cross it at a right angle. The gradient to this line equation will be a negative reciprocal of the original gradient. So here I've got a graph with a line going up, which is y equals x. A parallel line to this we've got going across here. As you can see, it will never ever cross with this line. And here is an example of a perpendicular line. And as you can see, it's at a 90-degree angle to the original. So we could also be asked to give a line equation which is parallel to the original line equation. For this, we've just got to remember that our gradient needs to be the same. So what we're actually saying is that our number before the x has got to be the same. So here's my line equation, y equals mx plus c. This number needs to be the same for the lines to be parallel. So for an example for this, I've got y equals 2x plus 1. I could give y equals 2x minus 20. I could even give y equals 2x. Both of these would be parallel to this because of our number before the x. Could be asked to maybe give a line equation parallel which passes through an exact coordinate. So y equals x minus 4 is my example for this, and I need it which actually passes through 1, 3. So just using my line equation, y equals x plus c. I haven't used the number before the x because I haven't got a number before it here. I've actually got an imaginary 1 in front of my x in these two examples. So y equals x plus 3. I'm now going to substitute in my y for 3, my x for 1. So I've got 3 equals 1 plus c. Now if I was to subtract 1 from both sides, or for those of you that like doing it, rearranging, taking my positive 1 from the right hand side to the left hand side, it will become a negative 1. That leaves me with 3 minus 1 equals c, which gives me c equaling 2. Now putting that back into the line equation, I've got y equals x plus 2. Because my 2 is positive here, I put a plus 2 after my x here. And that is my solution to this. That is my parallel line that would pass through this coordinate. So anytime that we're working out for perpendicular lines, like we mentioned previously, we are going to be working with the negative reciprocals of the original gradient. So y equals mx plus c, you'll see this throughout the examples. My example will be y equals 2x plus 1. Now, my negative reciprocal of 2 is going to be negative 1 over 2. But we could also calculate this. So if you're not sure about working with reciprocals, the negative reciprocals, we can use this rule. Anytime that we are multiplying our original gradient with our perpendicular line equation gradient, the answer will always be negative 1. I could rearrange this to calculate my new gradient. Bear in mind that this m1 would be multiplying. So if I took this from this side over to this side, it'll be negative 1 divided by m1, or I could divide both sides by m1. So as an example for this, I've got y equals 3x minus 4. So if I substitute in my 3 for my m1, because this is my original gradient, my new gradient for my perpendicular line will be negative 1/3, or 1 over 3. So a perpendicular line equation for this, I could give y equals negative a third x minus 4, just as an example. Could be asked to actually give a perpendicular line equation passing through a coordinate, just the same as for the parallel lines. So here I've got y equals 2x minus 4, and I'm looking for a perpendicular line that passes through to negative 6. So remembering to calculate my new gradients for my perpendicular line, it's going to equal negative 1 over my original gradient. So that's going to be, substituting my 2 in, my new gradient is going to be negative 1 over 2, or negative half. So I've got y equals negative a half x plus c, because obviously I've been given this coordinate and I've got no idea where it's going to intercept the y-axis. Substituting in my negative 6 in for my y, substituting in my 2 for my x, and then multiplying out. Negative a half times 2, that will give me negative 1. If I took my negative 1 from the right hand side over to the left hand side, it'll become plus 1. So I end up with negative 6 plus 1 equals c, because c was still left on itself on the right hand side. So adding 1 to negative 6, that gives me negative 5. So I found out what c equals. So now I can put that back into my new perpendicular line equation. So for this, I'd have y equals negative half x minus 5. Now we can check if this gradient is actually right by remembering that if we multiply our original gradient with our perpendicular gradient, our answer should be negative 1. And as you can see, 2 times negative half, that certainly does give me negative 1. So I know the gradient is correct. If you like what you see, please subscribe. Thank you very much for watching.